Let's solve some problem-solving questions using linear systems. Okay, so example 1. Christian has a total of 8 cars and trucks to play with. His birthday is soon. He hopes to double the number of cars he has now. If he does, he will have a total of 11 cars and trucks. How many cars does he have now? And how many trucks? Okay, so first, we would have to create an algebraic model that represents this situation, right? But let's pay attention to some of this. And sorry, by the way, you may want to pause the video to copy this down. I'm just gonna keep on going. So 8 cars. Okay, let's underline this. He originally has 8 cars and trucks. We don't know how many of each, either cars or trucks, he has, but he has a total of 8. And for his birthday, as it says here, he hopes to double the number of cars. The trucks will remain the same, and at the end he will have a total of 11 cars and trucks. Okay, so these are important things. So let's create an algebraic model for the current situation, which is he has 8 cars and trucks. Now, how would you show that algebraically? Maybe you want to try this on your own, pause the video and check it, but this is how we could approach this example, right? We know that he has a total of 8 cars and trucks now. We don't know how many cars does he have. I'm going to use the letter C for cars. But if we add the number of cars plus trucks, the letter T for trucks, if we add these two, we're going to get a total of 8. And it says later on that he hopes to double the number of cars for his birthday. So we don't know what the original number of cars is, but for his birthday he hopes to double it. So that would mean you would multiply the original number of cars by 2. So 2 times C. And if we add the number of trucks, he is going to have a total of 11 cars and trucks. So there you go. These are 2 original equations, and the question says how many cars does he have now and how many trucks. So at this point, if you got this the same equation, then well, good for you. Now try to figure out what the number of cars and trucks is. So let's keep on going. So first, just like before, I'm gonna label this equation as equation 1, this one is equation 2, and here you can use either the method of substitution or elimination. It depends, whatever you're more comfortable with, whatever you feel would be best for this, right? In this case, I'm actually going to use the method of elimination. You may have chosen to use the method of substitution. That's perfectly fine. By the way, here C and T, we know that means there's nothing written. The coefficient is 1. Okay, so first, I'm going to use the method of elimination. I'm going to start eliminating the letter T. So I have to subtract both equations. So we subtract. Let me move this up a bit more. So we subtract equation 1 from equation 2. That's gonna give us, okay, so 1c minus 2c, 1c minus 2c, that gives us negative 1c, plus 1t minus 1t, that gives us 0. So I'm gonna write it, and then 8 minus 11, that gives us minus 3. Okay, and then c becomes negative 3 divided by negative 1, that gives us positive 3. Alright, so that's our number of cars originally. Okay, and now with this we can find out what the number of trucks are. And you can see, right, we can substitute the number of cars, which is equal to 3, into equation 1, and then we can solve for t. So let's do that. So that means this becomes 3 plus t equals 8. 3 plus t equals 8. And then t becomes 5, right? So plus 3, it moves to the other side as minus 3, 8 minus 3, that becomes 5. So this means that Christian has 3 cars and 5 trucks at this moment. Okay, so let's write this down. So therefore, we can say therefore, right? So we can say now that Christian now has 6 cars and, oh, not 6 cars. Christian has now 3 cars and 5 trucks. So it's 3 cars and 5 trucks. Okay, 3 cars now, right? And after his birthday, of course, he hopes to double, so he hopes to get 6 cars. And then, of course, if you check 6 plus 5, that gives us 11, which is what we expected after his birthday, of course.